So welcome to our second video on factorising quadratics. Although technically speaking the title is a little bit misleading because we're not actually going to be dealing with quadratics in this one. We're going to be dealing with expressions that are a different order, but we're going to apply the same principles that we just looked at with our quadratics to these expressions. And they've got a certain structure that allows us to do this. So here we go. So we've got three completely different looking expressions here. This one is a power 4. Here we've got x that contains some square roots, and this one we've got something using power law, so we've got 3 to the power 2x, 3 to the power x. But the key with all of these, the similarity that they've got is that the middle term, so in this case it's the root term, and this one's the square term, over here it's this one, is the power of the middle term. It's always half the power of the one in front. So this is power 4, that's power 2. This is power half, power 1. You see this power here, it's double that one there. And that allows us to factorise in the same way as we did with quadratics, because a quadratic already has that structure as well. So here we go. All I'm going to do is look at this and say, well, let's set up my structure with brackets. And by putting that as 5x squared and x squared, that's how I'm going to get 5x to the power 4. And the middle terms, let's say if I put a number there and there, if we do x squared times by that, it's going to give us an x squared term. So that's going to give us the middle terms that we're after. So if we put in 3 and 1, because we know the numbers in the brackets have got to multiply to make 3, and at the same time they've got to add to make minus 14. And you can see from here we've got 15x squared. From this one we've just got 1x squared. I can make 14x squared quite happily just by making that the minus. So let's put the signs in. There we go. And there is our factorised power 4 expression, but using, let's say, exactly the same structure and principles that we had before. Exactly the same idea with this one, because let's say the first term is power 1, that one is power half. So let's set up my brackets with roots at the front of each. So now I just need two numbers that multiply to make 24, add to make 5. That's going to be 8 and 3. There's the signs. And there we go. Again, we've managed to do some factorising. And the third example. Now, there's a couple of ways of going about this, so I'm going to show you both. One way to do it is say, well, let's just use a substitution. Just try and take that horrible looking thing with the 3 to the power whatevers, and just make it a little bit more simple, break it down to something that looks more familiar. And we can do this by using a substitution. So say, okay, let's just call the variable y, and we'll say, let's make that equal 3 to the power of x. What that means is y squared would be 3 to the power x squared, which is 3 to the power 2x using our power law with the power inside and outside the bracket. And what we've done now is we've got 3 to the power 2x, that's that bit there in terms of y, and 3 to the power x, that's this bit here in terms of y. So what we can do now is use that substitution and put those things into the equation. So let's first of all look at this first term. 3 to the power 2x we said was the same as y squared. 3 to the power x we said is y. The number is still exactly the same. So now by using that substitution we've changed our original expression into something that looks a bit more familiar. And so now I'm just going to do the factorising. Two numbers that multiply to make 48 and add to make minus 2. That's going to be 8 and 6. And there it is factorised. But remember, the last thing you've got to do with this one is go back and effectively reverse that substitution, because you want your expression to be in terms of 3 to the power x. So what we're going to do is just take the y back out, put the 3x back in, and there it is factorised. Now, the substitution allows you to just break that expression down to something that's a bit more recognisable. If you're feeling comfortable, you can just do it and the same as before, as long as you recognise that we're going to be needing 3 to the power of x at the front of each bracket. So set up your structure, and clearly again it's just a case of now on. There's our 3 to the power 2x, put in the 8, put in the 6. That's going to give us our minus 2 lots of 3 to the power x, and there we go. We're sorted.